Hello. I just wanted to say hi before we started our new video. You may or may not notice I gave myself a Corona cut, as people are doing nowadays. I gave myself a Corona cut this weekend because my hair was just a little too long for me to have to deal with. It was too much hair, so I cut a whole bunch of hair off. This is me. That's just hair. It'll grow back, right? So I just wanted to say hi before we started our notes. All right, so let's get busy. All right, so I gotta turn this around. All right, we are going to start our new unit. New unit is about scientific notation. So we are going to convert. So convert means change. Standard form to scientific notation. All right, and here we go. We are on page 80. Oh, we might have to go back. We're on 83, actually. So, let me fix that. Let's do this. We're going to draw arrows down. We did an extra page of practice that I didn't label in my notebook. All right, so page 83. And we are going to title this Standard Form to Scientific Notation. And we're going to talk about those vocabularies terms really quickly. So standard form, standard is what we normally just talk about for math numbers, right? So our normal math, the numbers that we're used to are standard form. So I'm going to put standard form, and I'm going to title these just regular numbers. So the numbers that we're just used to seeing, like the number 14,785, that's standard form, or 0.00076, that's standard form, right? Or negative 18.054. Those are all just standard forms. Those are the numbers that we're used to dealing with. And we're going to be taking these numbers that we're used to dealing with, but we're really going to be dealing with really, 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 really big numbers or really, 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 really small numbers, right? So that's the kind of the purpose of standard or of scientific notation. Scientific notation is when you take this number that we use on a regular basis, but it's a really big number. It's kind of hard to work with or hard to read correctly, especially, or it's a really, really small number, so it's hard to read. And we take these really big numbers or really small numbers and we make them easier to work with or easier to understand or easier to read. So for example, like numbers that are in the billions, right? Or even larger than that. Those are the types of numbers that we're going to be changing, right? That's a really big number. We're going to be changing that into something that's a little bit easier to work with. So a scientific notation, if we're talking about scientific notation is when you convert a really large or a really small number into a more manageable number to talk about. So it consists of a decimal times a power of 10. And so we're going to walk through the steps of how to convert these numbers from standard form to scientific notation. So just for an example, I'm going to give you a really big number. So if I had the number, let's go with 487, and then I'm going to put a lot of zeros behind it. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? Like this is a huge number, right? So this is huge. This is a really big number, and it's written in standard form. So this is standard form. But it's so big, I don't really know how to read it correctly, right? Like I know that this is the hundreds, thousands, millions, billions. This would be trillion. So it would be 487 trillion. But I have to work backwards to read that really big value. And so instead of talking about this really big number and trying to read it without knowing all of the place values, I could rewrite it in standard form and it would tell me just kind of how big it, or in scientific notation, excuse me, and it would tell me just kind of how big that number is. So I'm going to write down some steps that we're going to follow to convert. So the first thing that we do is find the decimal in the original number, right? So in this original number, I need to find the zero or the decimal. And so if I'm looking, I don't see a decimal. My decimal in this number is actually right here. It's hidden. So sometimes you have to put that decimal in there. If it's a whole number, sometimes you have to give the decimal at the very end so that you can find it, right? Because we're not going to put a point at the end of it and then put a zero behind it. That's kind of redundant. So I need to find that decimal, and sometimes that means I need to put the decimal in. The second thing that I do after I find that decimal is I'm going to move the decimal so there is one non-zero digit to the left. All right, so if I have my decimal right here and I want to look at the left, and remember the left is this way, there are a lot of digits to the left of my decimal. So I'm going to move it until there's only one non-zero digit, meaning a digit that's not zero. So I'm going to keep going, and I'm going to keep moving it until I only have one digit that's not a zero to the left. And I'm going to stop right there because I have one digit, one non-zero, it's not a zero, digit to the left. So I moved it all the way over there. Step 3 is to write the new decimal. So if I look, I moved this. My new decimal is 4.87. And then I don't need any of these zeros because there's nothing behind it that's not a zero, right? These zeros are all done. They don't really mean anything to it. So I'm going to write, I'll do it in a different color. I'll do it in black so it's easier to see. I'm going to write 4.87 because that's my new decimal. Then I count the number of moves in step number 2. So I'm going to count how many times I moved the decimal up here in step number 2 when I moved my decimal from the end all the way behind the 4. This number is your exponent. So I'm going to count. I moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I moved 14 times. This number is my exponent. So 14 is my exponent. And then you're going to times the decimal by 10 and the exponent. Because when you multiply by 10, multiplying by 10 just moves your decimal one place. It adds a 0 to the end of the problem. So 4.87 times 10 would move it one time. But I don't want to move it one time. I want to move it 14 times because that's how many moves I made. So I'm going to do 10 to the 14th. And that is my scientific notation. All right, so we're going to practice. And there's one extra little thing that we need to talk about. So I have my rules right here. And we're just going to practice with pens over there with some values. So let's do 5, 6, 8, 0, 0. So not as big of a number, right? But my steps are still the same. I need to find the decimal. Step number 1, find the decimal in this problem. So in this problem, my decimal is actually right here. And I'm going to move it 1, 2, 3, 4. Because I want one non-zero digit to the left of the decimal. So here's my decimal now, and there's one non-zero digit to the left. So I'm going to write 5.68. I don't need those extra zeros because there's nothing behind them. Write the new decimal. Count the number of moves in step 2. This is your exponent. And again, I moved 1, 2, 3, 4 times. So I'm going to times by 10 and to the 4th. And if, let me grab my calculator, I can just show you. 5.68, right, times 10 to the 4th is this number. Right, so there are just two ways of writing it. So let's do another one just to get the hang of these values. So if I did 10800000, there's my number. So I'm going to find the decimal and the original number, which is right here. And I'm going to move it until there's one non-zero digit to the left. So I'm going to move, 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 move. Right there. There's one non-zero digit to the left. My decimal is 1.08, but I don't need these zeros because there's nothing else behind them. I count the number of moves that I made. 1, 2, 3, 4, 5, 6 times 10 to the 6th. And again, it's always times 10 because multiplying by 10 moves your decimal one time. So that's why I'm multiplying by 10. And then I'm moving my decimal 6 times, so that's why it's 10 to the 6th. There is one trick about it. So these numbers are really big numbers, right? If someone said, hey, Mrs. Long, I'm going to give you $56,800, I'd be like, done, sign me up, right? These are really big numbers. This can also be used for really small numbers, right? This is a very, very small number, right? It's a decimal. It's a number way less than 0. So the difference with these types of problems, it's pretty much the same steps, except there's one change. And here we go. I need to find the decimal in my original number. Well, it's right here. There's actually a decimal in this number. And I want to move the decimal so there's one non-zero digit to the left. Well, if you look, my decimal is at the beginning of the problem, whereas up here my decimal is at the end. So I'm not moving my decimal this way. I have to move my decimal backwards. So I need to move it until there's one non-zero digit to the left. So I'm going to keep going. And I want one digit to the left. I now have one digit to the left Have to know the difference between your left and your right of the decimal. So my new decimal is now 7.56 times 10, always times 10, and I'm going to count how many moves. 1, 2, 3, 4, 5, 6, 7. But it's not going to be to the 7th power. It's going to be to the negative 7th power because I'm moving the opposite direction. Up here, when I was moving, I had started with a big number. I had a positive exponent. Here I'm starting with a little number. I'm going to have a negative exponent. So let's try another one. 0.000004056. Why not? All right, find your decimal. In this problem, it's right there. It's given to me. And I'm going to move the decimal so there's one non-zero digit to the left. And remember, the left is this way. So I'm going to keep moving, keep moving, keep moving, keep moving, keep moving, and stop right here. I want to stop because I want one to the left of the decimal. One digit to the left of the decimal. Don't go all the way to the end. I want one digit that's not zero to the left of the decimal. So 4.056 is my decimal times 10. How many moves did I make? 1, 2, 3, 4, 5, 6 moves. So my exponent would be 6, but it's not positive 6. My number to begin with was really small, and since I started with a number less than 0, I'm going to have a negative exponent. All right, so to keep in your head, if it's a big number, it's a positive exponent. If it's a number less than 0, it's a negative exponent. So let's write that down. So, and again, big number, right? Large number. It's a positive exponent. If it's a small number, less than 0, it's a negative exponent. So you're going to follow these steps for every single problem. Find the decimal in the original number. Move it so that there's one non-zero digit to the left. One digit to the left. One non-zero digit to the left. Even going backwards, I have one non-zero digit to the left. One non-zero digit to the left. Write the new decimal. Count the number of moves. That's your exponent. We always times by 10 because timesing by 10 is when you move that decimal. Decimals get moved by 10, right? Multiplying by 10 adds another place value. And then your exponent for your number of tens is the number of moves.